Hello everyone, I'm Zu-Ming Jiang from Zurich. I'm happy to be here to present our work on a new and effective approach in finding transactional bugs in database engine. This is joint work with Manuel and Zhendong. So let's first introduce what is a database transaction. Suppose John wants to transfer $100 to Mary. Intuitively, the database engine inside the bank will execute two update statements. One is to decrease the money in John's account, and another one is try to increase the money in Mary's account. However, something may went wrong if the first update statement succeeds and another update statement fails. In this case, the $100 will disappear. It does not exist either in John's account or Mary's account. Transaction could be used in this case. It grows two statements together with a start transaction statement and a commit statement. By doing so, the whole transaction can either completely succeed or completely fails. No partial success or failure will happen. And thus, it could prevent the money loss in the previous case. Because of the powerful feature, transactions have been used everywhere in the world. Besides the banking and finance, transactions also are applied in the area like healthcare, airline, and social media. So it is very important to make sure the transactions are correctly executed. Otherwise, our life may be disordered. In the real world, one database engine commonly receives several transactions at the same time. We could use a graph to represent their data processing. If two transactions are processing different data, it is trivial and easy for the database engine to handle because it could just simply fork two processes to execute these two transactions respectively. However, when two transactions are processing the same data to get the correct result, the database engine should very carefully to control the transaction execution using let's say concurrency control mechanism like multi-version concurrency control or two-phase locking. This part is very complex and very difficult for a developer to implement them correctly because of it involves concurrency. So bugs are easily involved here. It's easy to detect a crash bug in database transaction because we just need to generate multiple transactions and then send this transaction to the database engine. If the database engine crash, we identify a crash bug. However, what if we want to find correctness bugs in database transaction? It's very difficult because there's no signal like crash to tell us whether the transactions are correctly executed. To solve this problem, if we were testing simple transaction, we could try to infer the expected result of transaction execution and then compare the expected result with actual result. If they differ, there's a bug. But it does not work when the transaction becomes complex. Here is an example of a complex transaction. There are two tables and two transactions interleaved here. We only need to focus on this statement. This update statement is complex because it uses a sub-select, and inside the sub-select, it uses an aggregate function minimum. Moreover, it uses a predicate, which means that it's difficult to predict which row will be processed by this statement. Because of this, it's very difficult to predict the expected result of this update statement. Okay, so our key insight to solve this problem is that instead of inferring the expected result directly, we could try to reorder the statement inside the predicate in a semantic preserving manner. And then use the reorder the statement to get the expected result. For this test example, we could reorder this statement in this way and then get the test case on the right-hand side. The reordered test case is not repeated as transaction, so there's no start transaction statement and commit statement. We theoretically make sure such reordering will not affect the semantics of the test case, and thus these two test cases should produce the exact same result. Okay, so let's see. We found that the test case on the left-hand side changed 2 rows of table 1. However, the update statement on the right-hand side changed only 1 row. So it indicates a bug. Actually, it is a real bug in MySQL. By using this idea, we have found over 50 bugs in 3 popular database management systems, MySQL, MariaDB, and TiDB. So let's introduce the approach with more detail. We first randomly generate several transactions and then send this transaction to the tested database management system. We could get the execution result, and then we analyze the result and the generated transaction and get the reordered test case. This reordered test case is guaranteed to produce the same result as the original one. And then we send the reordered test case to the database management system again and get this execution result. This result is used as oracle. Lastly, we compare the execution result of the previous original test case and the reordered test case. If their result differ, we identify a bug here. So the analysis and reordering process is our key technique. So let's give more detail about it. We still use this test case as example. We first extract the statement dependency graph, which is proposed in our paper to describe the statement's result, whether the statement result are depending on another statement execution. It is a directed graph. And then based on the graph, we topological sort it and then get the sequence. According to the sorted sequence, we can get the reordered test case. Finally, we compare the result of these 2 test cases and find that they produce different results. So there's a bug here. So we implement this idea and approach in an open source tool, TxCheck, and this is the GitHub repo of the TxCheck. We use TxCheck to test the 3 database management systems, as mentioned before, and we have found 56 bugs in this database management system. Among them, 30 bugs are found in transaction execution, and 19 of them are found by our oracle. So lastly, let me conclude the work at the end. So it is very difficult to find the correctness spot in database transaction because there's no oracle to tell us whether the transactions are correctly executed or not. It even becomes worse when the transactions are very complex. To solve this problem, we propose a general idea where we could reorder the statement inside the transaction without changing the semantics of this transaction. We use the reordered test case as oracle to validate whether the original test case produced the expected result. We implement the approach in an open source tool, TxCheck, and then we use TxCheck to test 3 popular database management systems and found totally 56 bugs in this database management system. Okay, that's all. Thank you very much for listening.